Hello, geometry students. Today we're going to be taking some notes on section 3.1 in your notes packets, if you want to get that out. Today we're going to be talking about what I think is a familiar topic to us, and it's on proving triangles congruent. Now, we've talked about this in Unit 2 as it relates to rigid motions. We just finished a unit where we talked about how perhaps after a particular line reflection, maybe it's a rotation or a translation, two triangles can map onto one another, and therefore all of the corresponding parts of those triangles are congruent. So what we're going to do to get started today is, as you can see the definition at the top, congruent triangles are two triangles that are exactly the same size and shape. Now, those terms size and shape, those are a little bit vague, and we've talked about that in class 2. It's really that the segments that are corresponding and the angles in the triangles have the same measure, right? So the line segments are the same length, and the angle measures are also corresponding and have the same measurement there as well. So if I tell you that in this particular diagram below that these two triangles are congruent, and again, this should be on page 1 of your packet, we're just going to figure out what are the corresponding angles and the corresponding sides that kind of match up. And I'm going to start with the sides here. So I'm going to make a list of sides that are congruent based on the fact that triangle ABC is congruent to triangle DEF. If I start, for example, with side AB of triangle ABC, what does AB correspond with? Well, one of the easiest things you can do is you can look at the congruence statement right here and say that AB matches up with DE. Okay, so in that order, AB goes with DE. So I can mark that those are congruent, and that kind of makes sense based on the picture. It does appear that if I drew a line straight down the middle, that triangle ABC would map onto triangle DEF. If I keep listing some corresponding sides that are congruent, if I go with the side on the left and I call it AC, AC goes from the bottom to the top, and just to match that up with the correct corresponding segment over here, I'm going to go from bottom to top again and use a double mark this time to say that AC is congruent to DF in the other triangle. And finally, last but not least, we have this third pair of sides. If these two triangles are congruent, then BC is congruent to, if I say BC, that would be congruent to EF. So those are all the pairs of corresponding sides that are congruent based on the fact that these triangles are in fact congruent. So then maybe off to the side here, we can list then the corresponding angles that are congruent as a result of this statement right here. And again, you kind of can match up the letters pretty easily. So if you have angle A, if I look across the way, should match up and be congruent to angle D. Sorry, that's a congruent symbol there. So angle A and angle D are congruent, perfect. And you're going to do the same thing for the other two pairs. So after angle A is congruent to angle D, maybe next we'll move on to B and E. So B would get a double mark here, B would be congruent to E. And then finally at the top of the figure, we have angle C congruent to angle F. So we'll use a triple marking up there. So this is kind of a big deal that when we talk about triangles that are congruent, all of the corresponding pairs of segments and all the corresponding pairs of angles would then be congruent as well and have those same exact measurements. So what I'd encourage you to do is maybe actually pause the video here for a second and try this next example. So the picture looks quite different, but what we want to do is list all the pairs of corresponding angles and all the pairs of corresponding sides that would have the same length, given this congruent statement that triangle RUS is congruent to triangle TSU. So hit pause, and then once we've taken about a minute there, we'll come back and we'll start going over these. Okay, so we start looking at some of those side lengths. Here's what I'm hoping you might have written down. So for side number 1, let's say I go with RS. If I look at RS, notice the order RS would go with TU on the opposite side. So I'm going to say RS is congruent to TU. So notice how RS went from bottom to top, but TU went from top to bottom. If you said RS and UT, it's not that big of a deal at the beginning of this unit, but that is something that we'll try and use this statement to help us pay attention to which pairs of corresponding sides kind of match up with one another. All right, if I keep going with that same pattern, RU at the bottom, what would that correspond with? Well, RU, the order here, would match up with TS. So RU is congruent to TS. And the last pair is this kind of shared side right down the middle that, because they both have this segment in common, You can either use a triple mark here, or what I'll commonly do throughout this unit is when there's a shared segment, I kind of put an X on it, so we might as well get used to that now. If I call it SU in the triangle at the bottom, what does SU correspond with? Well, SU actually goes with US in the other triangle, okay? So if you go SU in that order from S to U, the third letter here is U, and that goes backwards to S. So again, if you say SU is congruent to SU, no big deal. Like, that totally makes sense to me. But technically, the corresponding parts will be listed in that specific order. Okay? So we've got all the sides written down. Let's talk about some angle measurements then. As far as the angles go, let's start with maybe an easy pair like angle R and angle T. So yeah, first letter here, first letter there. Those are easy enough to match up. Angle R is congruent to angle T. Moving on to the other pairs you have to be a little bit more cautious about, because you can't really name them with just having one letter. If I say angle U, for example, angle U could be the bottom half, the top half, the whole thing. So when I talk about another pair, like maybe I'll name the angle RUS. So angle RUS. And RUS, let's see if that's actually the order of this triangle RUS. So without even looking up top, I know it has to go with TSU. Angle TSU. And if I go ahead and match that up, TSU would be this angle right here, and that's kind of where I thought it should be based on how this picture looks. Okay, and then last but not least, the third pair you can name with 3 letters again. You can say RSU and TUS, but I'm actually going to get fancy on you here and put a 1 and 2 in those spots. Okay, so when I put a 1 and 2 in those spots, you can actually say that angle 1 is congruent to angle 2. And that will be something that we commonly do throughout this unit, where we might name an angle with a number, which we've seen before, and then maybe just state that those 2 angles in the diagram are congruent. It actually makes our job, in my opinion, just that much easier. Okay. One thing I do want to reference, which is kind of a big deal in Unit 3 here, is something called the reflexive property. And as far as the reflexive property is concerned, we actually used it in this last example without knowing it. So the reflexive property is when you have this shared segment right here that winds up being congruent to itself, but it's a pair of corresponding parts that are congruent between these 2 triangles. So what I want you to fill in for the definition here is a reflexive property is a shared segment. And what I want you to put next to that is that in certain examples later on, it actually could be a shared angle. So it doesn't have to be a segment, it could be a shared angle that is congruent to itself. Okay, so reflexive property, like I said, it's actually kind of a big deal in this unit. It doesn't seem like that crazy of an idea that something's congruent to itself. However, we're going to see it come up a lot in Unit 3 with our triangle proofs that we'll eventually get into as soon as our next lesson. So if we're good with page 1, I will actually invite you right now to start looking for a compass. And if you have to pause the video to find your compass, that's fine by me. But in this, we have a couple of investigations today that will involve a compass, and this is the only time we use it in this unit. But we're going to investigate a triangle congruence method called side, side, side. And what I would like you to do is make a triangle using these exact 3 side lengths. So we're going to create a triangle that has one side this length, one side this length, one side this length. And I'm going to show you how to do it up here, but if I were to walk around right now and see everybody's papers, I bet everybody might have something that looks probably a little bit different on their pages. And I'm going to take my straight edge and I'm going to line it up towards the bottom of the page. And I'm going to start by just kind of drawing what we would have called earlier a reference line. Okay, so I'm going to draw this. Probably just make it a little bit longer than the given segment up here. Okay, so once you draw that line in, then what I want you to do is measure the segments that you're given up top here. Okay, so that first segment, open your compass to that width, and then copy it down to the reference line. So sorry, I'm going to be twisting my paper here a little bit. Okay, so there's copy number 1. Okay, so right now what I know is that this length right here up top is the same as this length down here when I connect. Okay. And then I have to just do the same thing with the other 2 lengths. We have to copy those over as well. So now open your compass up to this segment right here. Okay. And it doesn't matter what end you start from, but I'm going to start from this endpoint right here on the right, and I'm going to swing an arc, and every point on this arc would have, if I connect from here to here or here to here, it has the same length as this segment. So to figure out where the third side of the triangle is, I'm going to just come up here one more time, measure this distance, okay, with my compass, and now just choose the other endpoint down on that reference line. So if I go from the left endpoint, swipe that smaller distance right there, okay, we're going to see that in the end, we can connect. And where those two arcs intersect, that has to then wind up being where the other two sides of the triangle meet. Okay, so we're going to connect this, and we're going to connect that. Okay. So if I go back to these two segments that were up here, and of course, if this is too fast, you can hit pause, right? So go ahead and mark that this segment had the same length as this one. And finally, the smallest segment has the same length as the smallest down here. What I was saying before is if I were to walk around right now and look at your pages, I bet everybody has something maybe a little bit different. Maybe your line wasn't this close to the bottom. Maybe it was drawn at an angle. But no matter what, if I were to walk around and measure these three sides, okay, everybody's three sides should have the same length as these three sides. And if I were to then take my protractor, which I actually do have one right here, and measure everybody's interior angles with this protractor, what we would find is that everybody's interior angle measurements at these three vertices would also match up and be the same. So for that reason, now that we've constructed this triangle with three congruent side lengths, the conclusion at the bottom is that side, 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 abbreviated SSS, is in fact a method to prove that two triangles are congruent. So the answer down here is very simply yes. Side, side, side works. And what today is going to be all about now is figuring out what other patterns with sides and angles are postulates that help us to prove triangles congruent. Turns out side, side, side is a yes. If you go on to the next page, you're going to see that there's a second investigation. It's not really much of an investigation though. Okay, so we have two different pictures that are partially completed. And at the top of this page, what I'll tell you is that this side is congruent to this side. If you measure and hold your compass open, you'll see that those are the same length. Okay, the bottom two lengths are also assigned to be the same, but you'll notice that in the investigation here, we're now talking about side angle side. So when we say that in that order, side angle side, the included angle is this one right here. So if you want to mark that arc, that these two angles would have the same measurement. Again, I hope you kind of trust me, but if I were to hold my protractor and measure the angle, copy it over here, you would find that those two angles have the same measurement. So is side angle side a congruence method? Can we prove triangles congruent using this side angle side method? And it turns out that the only way to connect the final 2 points, if you have this side angle setup, is to connect from this vertex to this vertex. Okay, and then same thing over here. Like the only way to finish the triangle right now is to connect those 2 points, just like we did a second ago. And you can even confirm that those two red lengths are the same by holding your compass and saying, yep, that distance right there matches this distance right here. So because of the setup here, and we didn't actually do a construction, we just kind of measured with our compass that these two final lengths are the same. If all three pairs of corresponding sides are congruent, that kind of actually brings you back to side, side, side. But remember that the initial condition was that we started with side angle side. And side angle side happens to be a second method that we can use to prove that two triangles are congruent. So the answer here is also a very resounding yes. We can prove triangles congruent by side, 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 but also if the given includes a side, an included angle, and another side, then that is another technique. Okay. Well, as you can see in the next line, there's actually 4 different methods that we can use to prove triangles congruent. So we're going to list those quickly now, and we could use similar compass techniques to show that the other methods work. But I'm hoping you'll trust me that if we list the first 2, side, 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 and side angle side, those are 2 that we will see commonly in triangle congruence. And then finally, the last 2 that we did not have a chance to look at with a compass would be angle, side, angle. So in that order, ASA, kind of the opposite of SAS from a second ago. And the fourth method we have over here is angle, angle, side. Now, if we look at those last two, notice how they both rely on knowing two pairs of congruent angles and only one pair of congruent sides. But that location of where the side is does matter. So maybe make a quick note of that the location of the side matters. If the side is kind of sandwiched in between the pairs of congruent angles, well, then I'm going to say it's angle, side, angle. But if the side is not directly in between the pairs of congruent angles, then we're going to default and say that it's angle, angle, side. That takes a little bit of practice to get used to, but again, don't worry too much about that right now. We're going to look at some examples below where there's some markings included in the picture. And based on the markings, we're going to pick which of these four methods could help us determine that the two triangles are congruent, keeping in mind there may not be enough information given. Okay. So for example, if I look at number one, I'm hoping number one's pretty obvious. You can see this side's congruent to this side, very large dashes here, right? We got a double mark here, double here, triple there, triple there. So the congruence method that proves this triangle congruent to this one is S, 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 side, side, side. Okay, so hopefully that kind of makes sense to get started for number one. When I look at number two, quickly across the way here, I see that this angle is congruent to this corresponding angle. And then we have the double mark on these angles here. But if I look up top, I don't see a method that says angle, angle. So that's maybe not quite enough information yet. One thing that we'll learn, though, is that in a diagram like this, we can do this marking from before. And if you remember what that's called, this is known as the reflexive property. When you have a shared side between two triangles, you can mark that with an X, and that would be a side that's congruent within both, since it's a side that they both share. So without any markings there, I know that this segment has the same length for the top triangle and for the bottom, thus making this setup angle, side, angle. So this is a case for angle, side, angle. When I look at the top triangle or the bottom, angle, side, angle. Okay. If we move on to something like number three, I will tell you that there's a marking in this picture that sometimes is not given to us, and it's this marking right here. And if you remember what this angle pair is called, these are called vertical angles. Okay, so sometimes that won't be marked for you in the diagram already. You'll have to mark that in advance, just like with the reflexive property. If you notice that that's in the diagram already, we know vertical angles are always congruent. However, when I'm looking at this diagram, I only see two pieces of info. I see one pair of sides, and I see one pair of corresponding angles. There's nothing up here that only has two criteria. It's three sides, two sides and an angle, or two angles and a side. So because we only have these two things marked, even though they may look as if they're congruent, this one has not enough information. So I don't know if those are congruent or not. There's not enough markings that were preset in the diagram for us to conclude that the top triangle is congruent to the bottom triangle. Okay. And you might be thinking the same thing about number four. I only see two markings. I see we have these segments congruent along the bottom, and then I see that these angles are both right angles. And by the way, we know right angles are both 90, so therefore these are congruent to each other. So there's no issue there. However, don't forget that we have, just like we had in number two up here, we have this reflexive property. This segment is shared between the triangle on the left and the triangle on the right. So if you mark that reflexive property, hopefully now you can see that the triangle congruence method for this one would be side, angle, side. So when you name that, you're just looking at one of the triangles. So if you want to even cover one up, you can see you have side, angle, and then the reflexive side. The angle is sandwiched right in between those two sides. So side, angle, side would be the method there. Okay. All right, moving on to the next page here. On the next page, we have a third method that we're going to, a third investigation, I should say here, that we're going to look into. And this third particular method is for angle, side, side. Now, angle, side, side, we already talked about those four methods. You have to be careful because this is not the same thing as side, angle, side, okay? So I have these two different triangles and I want to see, based on knowing this angle, this is not a known side, this is just a dotted line to help us. Okay, this side and this side. Do we see how it's angle, side, side? Not the same as SAS that we just talked about, side, angle, side. What I'm going to do is just look up here for a moment. I'm going to use a wiki stick, and I'm going to see if I create a length of that side of that length, can we only make one triangle ever given an angle, a side, and a side? And what winds up happening is if I take this particular length and I start swinging it, I'm going to hold this point up here and I start swinging it down towards the base. What you're going to see is you can at least make one triangle given angle, side, and side. So again, that side was the exact same length as this side right here. Okay. Same thing here. I'm going to hold that wiki stick again and I'm going to slide it this way. Okay. And when I do that, and I slide the wiki stick, what we'll find is for the second method, is this the same length? Oops, it's a little short. Hang on 1 second. Bear with me. Let me fix this one. Okay. This is a little long, guys. All right. Cut that off a little bit. Okay. Let's try that again. All right, here's the length. Okay, when I slide it initially, it looks like this, right? If I go back up to the top picture, we can definitely make one triangle out of that. If I use that same length down here, what you may notice is that if I start swinging that side this way a little bit further, you can make a second triangle with that same length. It's really narrow and obtuse, right? You get this obtuse angle here, but there were actually two triangles that can be made. You can make an acute triangle up here, or you can make an obtuse triangle down here, which is a little strange. So as it turns out, the criteria angle, side, side is not enough to prove two triangles congruent, because I can make two different triangles with these three measurements, angle, side, and side. In fact, if you want to justify that real quick, what you could do is you could take your compass, hold it open to the exact width of this second segment up here, and then what you can do is you can swing an arc. This might illustrate it even better. So if I swing an arc, notice how it's going to hit down here twice. It hits once here and once over here. So if you connect both of those back to this point up here, remember that these segments have the same length right now. As it turns out, you can make two different triangles from that given criteria. Okay, angle, side, side. So because we can make two triangles, if you have angle, side, side marked in a picture, we can make two triangles, and therefore, will angle, side, side prove that two triangles are congruent? The answer is a big old no. It is not enough information. And we're going to talk about one final technique then. Angle, side, side definitely doesn't work. Last technique then is angle, angle, angle. Will that work? And the way we're going to justify that one kind of quickly is one more compass construction. It says to construct two equilateral triangles with the following given side lengths. So we're going to do an equilateral here and an equilateral here. Hit pause for a second and see if you remember how to do an equilateral triangle. Okay, if we are back, okay, I'm going to open my compass to the exact width of that segment, swipe an arc above, and then switch it to the other side. Same thing, swipe an arc. Okay, so there's the first one. So if I connect that point at the top to each of those vertices, this is an equilateral triangle. 1, 2. Okay, so there's one equilateral. Let's do the same thing over here. Open your compass to that exact width. Perhaps you already have this done. Okay, swipe your arc, and then do the same thing from the other side. Swipe that same arc where those intersect. Connect back to each end of the segments. Okay. And why did these two equilateral triangles wind up proving a case for angle, angle, angle? So the question is, will angle, angle, angle prove that the two triangles are congruent? Well, what you can do at this point is, because these are equilateral triangles, we know they're also equiangular, which what that means is that all the angles have to be 60, 60, 60, 60. Because if all three sides are the same, all three angles are the same, 180 divided by 3 is 60. Same thing over here, like these have to be 60 as well. So notice how all the pairs of corresponding angles match up and they're all 60s. And if I look at these two triangles based on the given segment length, Will angle, angle, angle prove that the two triangles are congruent? They look similar to one another, which is actually by definition what they are, but they are not congruent to each other. They definitely don't have the same side lengths. So if you have 3 pairs of congruent angles marked off in 2 diagrams, that's not enough info. It could look like this, that the angles are all the same, but the segment lengths are not necessarily the same. So the 2 methods that we just looked at that are not sufficient to prove that 2 triangles are congruent are angle side side, like we just saw. We saw we can make 2 triangles there. And certainly this last case of angle, 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 that does not work either. So the last thing we're going to do in the notes before we get to some more practice here is taking a look at number 1. Is this enough information to prove that the 2 triangles are congruent? Well, if I take a look at number 1, we saw this picture earlier. The first thing I'm going to jump in and mark is that reflexive side. Because now we have 3 pieces. We have 2 angles, and then we have 2 pairs of congruent sides. We've got the reflexive and this right here. However, if I look at the order goes angle, side, side. This is not side angle side. If it was side angle side, the angle would have been marked up top here to get side angle side. Angle side side is a no for many reasons that we'll discuss, but angle side side is not good. Okay, so that's not a congruence method. In number 2, are these 2 triangles congruent? Well, there's nothing marked except for this on these 2 sides. And what I'm hoping you remember about that is it means that they're parallel. Okay, when lines are parallel, these special angles are congruent. They're alternate interior. And I can even mark these pair on the other diagonal there as being congruent alternate interiors. Finally, there are a 3rd pair of congruent angles here, and it's the vertical ones. So you get this one congruent to this one. So if I look at this, I've now marked off that 3 different pairs of angles are congruent, but what we just said a second ago is if you have angle, 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 that is a no. It is not enough information to prove that the 2 triangles are congruent. Okay, angle side side, angle, 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 they're both no-goes. But finally, for these last 2 pictures, we're going to use the same property in both. Check it out, reflexive. Is this the same case as the one up above it where we had angle side side? This is a different setup now because what I mentioned before is that this one's side angle side. It's exactly where I pointed to up in that picture, side angle side. This one works. So this is a yes, the triangles are congruent by side angle side. And then for this last one, we've also seen a picture that kind of looks like that today, where again, we have that one last time, the reflexive side there. And in that marking, do we have enough info? If you have 2 angles on a side, that's always good enough. 2 angles, 1 pair of congruent sides is good, but which one is it? Is it angle side angle, or is it angle angle side? I'll give you a second to think about that while I find a different color here. Which one is it? Drum roll, please. The final answer is, it is angle, angle, side, okay? If this was marked right here, the side would be sandwiched between the 2 angles. I think of the angles as a piece of bread and the side right in the middle, okay? But since the side is not included between those 2 angles, it's off to the side. Angle, angle, side is the method that says, yes, these 2 triangles are congruent. So part of the homework tonight will be involved looking at pictures just like this, trying to pick which method proves the triangle's congruent. But lots more to come in this unit with triangle congruence and the postulates that get us there. So great job today, everybody. We will pick up with some proof vocabulary in our next lesson.